What we've done now to our work. God, I'm so sorry. I'm so sorry.
I can't say all that, Mr. Masters.
We'd like to do that again.
Yes, we would.
Gee whiz. What have you got in there?
I wanted to show you my water collection.
Your water collection? You collect water?
Yeah, why not? I mean, people collect stamps and butterflies. I mean, why shouldn't I collect water? It's more valuable than those things.
Well, I can't argue with that.
I got this ocean water for my spring break in Florida.
Gee, all I got was a sunburn.
Do you know how much water is in the ocean?
Billions and billions of gallons, minus about a quart.
No, 97% of the Earth's water is in the oceans.
Oh, see, I thought you wanted an exact measure. Sorry.
I got this snowball from the blizzard of '94.
What have you got, a refrigerator in there?
Did you know that 2% of the Earth's water is in the polar ice caps and glaciers? That leaves only 1% for the rivers, lakes, and streams.
And that's where we get most of our drinking water from.
Out of all the water on Earth, we only get 1% of it to drink.
No wonder it's so important we keep it clean. Gee whiz.
No.
Gee whiz in agriculture.
Well, now that we've got that out of the way, what else have you got in there?
I've got bottled water.
But I bet you don't have one of these. Bet there's no watermelon in that suitcase.
You're being funny, aren't you?
No, really. Water is a major part of watermelon. That's what makes it so refreshing on a hot day. Got milk?
Look, just because it's liquid doesn't mean I collect it.
No, really. It takes a dairy cow 3 gallons of water to make 1 gallon of milk. And it takes 50 glasses of water to make 1 glass of orange juice. Here, let me demonstrate. 1, 2, 3.
I get the picture.
And you know, if you're going to have a really top-notch water collection, you got to get some living things in there, like an elephant and a fish and a puppy and a tree and an amoeba.
I don't think my parents would let me. Our house isn't all that big.
But you got to have some living things in there. Every living thing's made with water. That's why water is more important than food or light. And you know, you should even be in that suitcase.
I'll pass on that thought.
But you, like every human, are 65 to 70% water. And did you know that in America every day we drink 110 million gallons of water?
Can I be excused?
What's the matter?
Well, all this talk of water and...
Oh, I get it. Yeah, you're excused. And while she's gone, we'll go visit with the Gee Whiz kids.
Gee Whiz kids! Gee Whiz kids! Gee Whiz kids, want to know?
Once water is dirty, can we ever clean it up again? How many forms does water take?
What's a watershed?
Is it true glaciers are melting?
Water everywhere, not a drop to drink.
What's the difference between surface water and groundwater?
What are heroes?
Water heroes? I don't know.
They're people who clean up water.
Can I have a hero sandwich? Once we use water, isn't it gone? You're all washed up.
What's point source pollution mean?
Why can't we drink seawater? If I don't take a bath, isn't that conserving water?
Why are some rivers brown?
What do caves have to do with the water supply?
Can I go to the bathroom?
Gee Whiz!
Maybe I shouldn't have left. Sounds like we have a lot of questions to answer.
Well, I can answer one of those right off the top.
Which one?
This one.
Once we use water, isn't it gone?
The answer is no.
No.
No. We have the same amount of water on the planet today that we've had since this planet was formed.
No way. I mean, gee whiz.
That's right. Water can take lots of different forms, but the total amount remains the same. Why, the water in this bottle could have been drunk by a dinosaur.
How does it go from dinosaur to bottle?
Great question. And a drip like you ought to be able to answer it.
Whoa, what's going on? Where am I?
You're water vapor in a cloud.
Me? Hey, I can see my house from here.
You're about to get a lot closer.
What's going on?
It's raining and you're a drop.
Better than being a drip. Ouch! What's going on now?
Well, you're in the soil now, making it possible for plants to grow. From there, you'll be traveling through the groundwater system.
But look at me, I'm all dirty.
Oh, that's just good old rich soil with a little manure and fertilizer thrown in.
Ew. Where'd all the brown go?
Well, the sand, rocks, and caves act like filters, and they screen out the stuff you picked up from the surface.
Whee! Hey, looks like fun. Dr. Kim, what was in that pipe? I don't feel so good.
Trash, pollution, ooh, trust me, you don't want to know. Feeling better?
Yeah, what happened?
Well, that's one of the great things about water. When it gets dirty, it can get cleaned up, just like people.
Ah, much better. Dr. Kim, help!
Well, you could have, but you might have ended up frozen for centuries in a polar ice cap. This detour is much more interesting.
Says you. Yuck! I don't belong on a tissue.
Don't complain, you could have come out the other end.
Now what?
Well, you're right back where you started. A drop of water vapor headed back into the atmosphere to become a cloud again.
Wait, this is one ride I don't want to go on again.
Are you okay?
Yeah, but next time you get to be the drip.
So tell us what you remember about your trip through the groundwater system and the river.
Well, the groundwater system was full of grass and soil, and I picked up a little fertilizer and manure.
And what do you remember about the river?
Well, it was fun at first, but then I passed the drain pipe that was dripping gooey stuff into the water. It smelled awful.
So what you experienced there were the two different kinds of pollution. The soil and other things in the groundwater system were non-point source pollution. And the icky drain pipe, well, that was point source pollution.
What exactly do those terms mean?
Tracy's at Hidden River Cave getting the answers to that question. Let's go see what she's up to.
I'm here in Horse Cave, Kentucky, where we're about to enter Hidden River Cave. Now, I've tracked down David Foster to help us clear up the confusion. Standing here at the opening of the cave, it's pretty, it's lush, and it smells really good. But it hasn't been that long ago when people couldn't even stand, like where I'm standing at now, without it smelling really gross, right?
That's right. Hidden River Cave was one of the most polluted caves in America. To understand what happened to Hidden River Cave, you need to understand karst. Karst areas are places where caves are found. Here in Hidden River Cave, the cave is surrounded by limestone rocks, which can be dissolved by rainwater to create enormous openings in cave passageways. Karst areas also have lots of sinkholes, which are places where the rainwater dissolves nice round depressions on the surface, and that rainwater goes underground to dissolve caves. Let's go down in the cave and see where the rainwater's going. When people first began living in this part of the world, they built their houses, farms, and their factories right over top of the cave. They didn't understand that the waste materials that they were dumping into sinkholes would come all the way underground and pollute our water supplies. In cave country, we have a saying, what goes down must come up, because this underground river down here eventually comes back out in the spring and flows into surface rivers.
You know, I'm sitting here looking around at how clean this place is, and think about how hard you and the others work to keep it this way and to make it that way. I mean, y'all are heroes.
Well, I wouldn't call us that.
I would. Whenever a water supply is cleaned up, a battle is won in the war to protect this great natural resource. Yeah, this could be any town in America. There are factories, farms, schools, homes. There are rivers and streams and maybe some caves. And everything is connected together. It's not a rumor. The runoff from a landfill or dump could land in a sinkhole. From there, it could go to an underground stream that supplies drinking water from a well. That would be very bad for you. Spilled crude oil or kerosene might land in a lake that gives life to fish, birds, and other animals. Bad for them, too. Chemical byproducts of industry could get washed or dumped into the river. And it's not just the other guy polluting our water. Yeah, it can happen in your own neighborhood. A broken septic tank in your backyard leaks sewage into the water table. Spilled chemical fertilizer and pesticide seeps into the ground or trickles into a pond. On farms, uncovered animal manure washes into the creek. Why should you be concerned? Many of these non-point source polluters contain microorganisms. Microorganisms that cause certain diseases. Organic and inorganic chemicals can also cause problems. Inorganic chemicals are things like metals, while organic chemicals include pesticides and industrial solvents. Trust me, too much of any of these things in our water is not good for our plants, animals, birds, fish, or you. But don't despair. Even though it's easier to pollute than to clean up, there's always hope as long as there are water heroes to fight the battle.
Geez, that guy should carry a mop.
Either that or we need to wear raincoats.
Hey, that reminds me. Do you know what a watershed is?
A really big raincoat.
Very funny. Actually, a watershed is any area of land that drains into a body of water.
Wouldn't that be everywhere?
That's right. We all live in some kind of a watershed. Here we've got a subdivision, like where you may live. We've got lawns and houses and cars. Over here we've got a new home being built. This is a golf course, and here's a water sewage treatment plant. This area has been logged. They've cut the trees off and left the hillsides bare. This is a factory. This is a farm over here, and we've got livestock production going on here and plant or cropping going on here. Then we've got our roadways and so forth. This is the body of water that it all drains into. Now, as you look at this watershed, where do you think most of the pollution comes from?
The factory.
Well, historically, a lot of the pollution did come from factories. When a factory is doing its job, it uses a lot of water, and that comes out of the factory as wastewater. Factories used to send that wastewater directly out into the water supply without treating it. As a result, it polluted the water supply. That's called point source pollution because it comes out at one point. Over the last 20 years or so, we've done a great job of cleaning up point source pollution so that now this is no longer the major source of water pollution. Instead, it's non-point source pollution. And we call it non-point source because it comes from everywhere. You can't really point to one place that it happens. Non-point source pollution gets into the body of water when it rains. So let's make it rain in our watershed and see how non-point source pollution happens. Over here on the farm, you can see how the soil has washed into the water from the crop field. The animal waste has washed into this stream here and off into our body of water. The oil has washed off the roadways and down into it. The chemicals, the fertilizer, pesticides, and so forth have washed off of our golf course and our lawns, and they've gone down into the stream and into the body of water. So non-point source pollution comes from all over the watershed, not just one spot.
Wow, there's a lot going on in a watershed.
Right, and a lot of different ways for pollution to get into our body of water. But there are things we can do to reduce that. If you were in charge of this watershed, what would you do to cut down on the amount of pollution that's getting into the body of water?
Block it.
That's right. We could add things to the watershed that actually stop pollution from getting into our body of water. The other thing we can do is reduce the amount of things out there that are available to roll into the water in the first place. Now we've redone our watershed here with some best management practices. Those are things that are going to reduce the amount of non-point source pollution that's going to get into our body of water. Now when we make it rain, all these best management practices are going to reduce the amount of non-point source pollution that gets into our body of water. Want to try? This time you can see how much clearer the water is because we reduced the amount of things that were out there to go into the water in the first place, and then our filter strips actually reduced the amount of things that were flowing off into the water. So did the crop residue, and so did the retaining wall. As a result, our body of water stays clean.
There's a lot of stuff to clean up out here. The liquidator wasn't kidding when he said we need more water heroes.
You want to meet some more?
Sure. Are they like the liquidator?
Actually, no, they look more like you.
Meet Tara and Tara. They're water heroes. This is Tara Franey, and this is Tara Fuller. They're members of the 4-H Environmental Club. They monitor the water quality here at West Hickman Creek. Now, who exactly does what and why?
I do the chemical test, which are pH, dissolved oxygen, and nitrates.
I'll be showing you the macroinvertebrates in the creek for the biology assessment.
Now, what is a macroinvertebrate?
It's an animal who's large enough to see with your naked eye, but it has no internal spine. It has an exoskeleton.
Now, they're all in this creek?
If the water's healthy.
Okay, so why don't you start collecting while Tara explains the chemistry part of it. Now, what are you looking for when you test the creek?
Well, I'm looking for the pH of the water and the dissolved oxygen and nitrate levels in the water.
And what is pH?
pH is how basic or how acidic the water is. Okay, so let me show you how to do the test. Okay, now we use the color comparator to see what pH it is. So which color do you think our sample is closest to?
That one right there.
So that means the pH is 8. And that's in the good range, which is from 9 to 6. Next, I test for the dissolved oxygen levels in the water.
Wait, oxygen's in the air. So how to get in the water?
Water should have oxygen in it from the plants in the water, or it can get mixed in while it's bubbling over rocks. In this test, I've already fixed the oxygen level. But now we need to find out how much oxygen is really in here. That means there's 9 milligrams per liter of oxygen in the water.
Okay.
On the scale here, you can find where 9 milligrams is, and it's in the good range. So that means there's a good amount of oxygen in the water.
Okay. And then the next test measures the nitrate levels. What does that show us?
That shows the nitrates level in the stream. And nitrates are not a good thing, and they can come from grass shavings being swept into the water or fertilizer running into it. One effect of high nitrates is a high algae level. Algae depletes the dissolved oxygen in the stream, in turn depletes the amount of macroinvertebrates.
Which brings us to Tara Fuller's job, finding animal life in the stream. Tara, did you find anything yet?
I could use some help.
Okay, let's do it. What did we find?
We have a wide variety of macroinvertebrates. We've got some crayfish right here. And we've got a clam. He has a little leech crawling on him, I think. We've got some damselfly nymphs. There's a leech right there, and I'm not going to pick him up. And we've got different types of macroinvertebrates. There's 3 different types. Leeches are a very tolerant animal, like right there, and so if you find leeches in the water, the quality isn't necessarily all that great. But if you find riffle beetles, then you know it's probably pretty clean water because they need cleaner water to survive.
What do you think is affecting Hickman Creek the most?
Well, there's runoff from fertilizers that gets down into the creek, and that's not very good for the animals. And also, when they built houses upstream, they forgot to replenish some of the natural growth around the stream. And roots from trees and bushes are important in preventing erosion, and they also provide shade to keep the water cool.
Okay, and is your group the only one worried about our water?
No, actually, there's a group in Fleming County that helps keep Fleming Creek clean.
In 1992, the Kentucky Division of Water found Fleming Creek to be highly polluted, to the point of dangerous. I'm here with Mr. Charlie Masters and Amber Dillon. In 1995, a team was developed by the Fleming County Schools to monitor the water quality here at Fleming Creek. Now, could you tell me a little bit about your group and how you came to work with the creek?
Sure can, Tracy. About 5 years ago, when some area farmers learned of the Division of Water study calling Fleming Creek one of the most polluted in the state, they became very concerned because Fleming Creek runs through the center of our county. It goes very near our largest town, which is Flemingsburg. So they came to me and they asked me if I could organize a group of students to monitor the creek on a regular basis. And since then, we've come out here about once a month, and we will monitor the creek on a pretty regular basis. We're looking for trends. We're wanting to know if the creek, is it getting better, is it getting worse, or is it staying the same? And we've been doing that since 1995.
Amber, could you tell me some of the major pollution problems here at Fleming Creek?
Well, most of Fleming Creek has dairy farms on both sides. And these farms are old, established farms, and they let the cows just have free reign. They just get in the creek, and there's animal waste, and it's just not a pretty situation. All these farms also have septic systems that are not up to date. They allow their waste, the water from the washing machine, things like that, to run straight into the creek, which causes a lot of problems.
Is it true that farmers took your advice on how to fix the pollution problems?
Many farmers have taken our advice. They've instilled BMPs, which are best management practices. Some are inexpensive, others cost a little more. Sometimes it's as easy as what we call cattle exclusion, which is just putting up a fence around the creek, around your ponds and things, and just to allow, make sure the cattle don't get in. Others are a little more expensive, the stack pad and the legumes, where you take the waste from your dairy cows and you stack it on these concrete slabs, basically, and the liquid waste flows down to the legume, and then you take the solid form of waste and spread it on your crops. During the winter, you plant a crop of wheat on your open fields just to make sure that erosion doesn't occur. We also have where we plant trees right along the creek edge to make sure that erosion doesn't occur. And we also leave a buffer area, which is 50 to 100 feet from the creek. You don't plant anywhere near that 50 to 100 feet, which is to make sure that the insecticides and pesticides don't get in the creek.
Yeah, those are great ideas, Amber. Here are some more best management practices. Remember, soil erosion is a big factor in water pollution. When farmers do things to prevent erosion, they keep soil where it needs to be in pastures and fields, and they protect the water supply at the same time. On the hillside, farmers can practice contour farming. That's when you plant crops in a descending circular pattern instead of straight lines. This decreases soil erosion. It is very important that farmers be trained and take special care in applying chemicals on their crops. If they put too much pesticide or chemical fertilizer on the crops, or if they carelessly spill chemicals, they've got big trouble. Water contamination can occur. Best management practices are not restricted to farmers. Building contractors, the logging industry, and homeowners can do things to prevent erosion. Replanting trees is the biggest tool in the fight against soil erosion. Just like the farmer, we need to use chemical pesticides and fertilizers carefully in our flower and vegetable gardens at home. I'm telling you this, never use more than you need and always follow the label. Listen to me now. We should look at our place in our local watershed and figure out how we can help protect this valuable, precious resource.
Y'all are definitely water heroes. How can we be water heroes too?
Well, when we first started doing this project, I ran into a lot of people that say, well, the water's not any concern of mine. I don't live on the creek. But actually, we all live uphill from some creek, and our waste products will wind up in the water somewhere. So we need to be really conscious about what we throw away and how we throw it away.
You can be a water hero too. Here's how.
Did you know that there's enough oil in your lawnmower to pollute over 1 million gallons of water?
Our streams are not our landfills, so dispose of your trash properly.
Fertilizers and chemicals usually wind up in our streams. Make sure you read and follow directions on labels.
Plant a tree can help save our creeks from erosion.
If you don't want to drink it, don't put it in the ground.
To conserve water,
turn off the water when you brush your teeth.
Take showers instead of baths. Baths use a lot more water.
Don't use the dishwasher or clothes washer unless they are full.
Put a brick or a plastic bottle in the toilet tank to reduce the amount of water used when flushing.
Water lines in the coolest part of the day. When there's a water advisory, do not wash your car or water your lawn. Make sure household and garden chemicals are disposed of properly, not in sinkholes.
We can all be water heroes!
What you doing?
I'm reserving pages in my autograph book for the Water Heroes.
You know, with a water collection, autographs, and all this enthusiasm, you could be a water hero yourself.
Gee, thanks. I'd like to be like the liquidator.
Well, there's only one liquidator, but you could be like the water heroes we met today.
Like David Foster.
And Tara Franey.
And Tara Fuller.
And Charlie Masters and the students at Fleming County High School.
We're water heroes!
Or you could be a professional water hero. You could be an agronomist, a soil scientist, a chemist, an engineer, or a water treatment specialist.
You know, there's one career you haven't mentioned yet.
What's that?
Water commando. How would you like to be turned into a big drip?
Gee whiz!
No.
Gee whiz in agriculture.